Back in late 2024, so only a handful of months ago, the first G-27 packaging standard went to ballot, and for the first time, it was approved. Now, we should be a little bit cautious by what we mean by the G-27 standard, because the actual intent of the whole project was to develop a packaging standard that would contain a thermal runaway inside of the box, right? So the thinking here is if we have a lithium battery or multiple lithium batteries that we want to ship on an aircraft, well, we need to put it in a package that when it goes to thermal runaway, there's going to be no flame escaping the box, no fragments. The box will not generate sufficient heat to ignite nearby materials. And sometimes the most difficult part to pass is that any off gas that results from that thermal runaway, oftentimes that off gas includes flammable constituents, flammable hydrocarbons, but any off gas that comes out of that battery cannot ignite inside of the test chamber. So this one, it's one thing, for example, to build a strong metal box that can contain flame, heat, projectile, but most packagings aren't going to be able to contain all of the gas. And so if you have off gas coming from the battery that inside of a small test chamber ignites, that's a failure of the test. So the packaging standard, it is extremely rigorous, but it's also, you need to think about it in terms of marrying it to the battery. So what I mean by this is if you need to put a battery in a box that contains flame, fragment, extreme heat, and off gas, it's extremely dependent on what battery you're using. So there are some batteries that just by themselves, when you hook them up to a heating coil, drive them to thermal runaway, they'll produce some heat. They may or may not catch on fire. They may have a little tiny amount of off gas coming from it. So at the end of the day, the type of package I need to contain those hazards might be an off-the-shelf cardboard box, right? Flip side of that is if I'm trying to transport a battery that is extremely reactive, that goes to thermal runaway, shoots flames, shoots fragments, well, any sort of flame or fragment is going to immediately burn right through my cardboard box, right? So the cardboard box is just not sufficient to contain those hazards. So then you need to start thinking about, okay, what other packaging solutions can I think of in terms of plastic packaging? Will that melt in high heat? Oftentimes, yes. So what other types of packagings can we look at? Well, we can look at metal packages with flame-resistant materials. So oftentimes for the most volatile type of batteries, the only package that's going to pass the G-27 would be some type of metal packaging with thermal performance materials built in. Because if you've seen lithium batteries go to thermal runaway, if you've been exposed to some of those tests, it's wildly variable in terms of battery safety and failure effect. Some batteries are relatively benign. I don't really love using the word benign, but that's why I'll say relatively benign. And then there are other batteries that are quite frankly scary in terms of the amount of heat they generate, the flames, the amount of gas that comes out of them. And so it's the entire packaging system is something that is completely dependent on what batteries you're looking to transport. And also thinking about scaling it up is you need to perform the tests as the package is prepared for transport. So it's not necessarily as simple as each battery has an assigned packaging, because what if you want to ship 100 of those batteries in a box? Well, as we've talked about already, now you start looking at the propagation effect, right? So if you have one battery, the test is done by setting one battery or one cell in the package to thermal runaway, and then observing for those things: flame, fragment, extreme heat, and off gas. So if you have now 100 batteries in the box, well, when you drive one to thermal runaway, it may produce enough heat to drive the next one to thermal runaway, and the next one, and the next one. There's so many different factors that go into this thing in terms of how batteries and packaging are married. The standard that was passed is extremely limited in scope, meaning that it only applies to lithium-ion cylindrical cells. And so the standard was approved by the SAE. It has not been adopted by any government around the world. So there's no requirement, for example, that you need to today put your batteries in some type of G-27 approved packaging that can contain thermal runaway. That is not the requirement as of today, but that is ultimately, I think, where we may be headed, that in certain circumstances, none of this has been completely developed or fleshed out yet, but it is imaginable that regulators will require batteries to go into G-27 compliant packaging in certain circumstances. So we don't really know how this thing is going to be applied once it's officially approved. And quite frankly, we still may be multiple years from this even kind of getting to the feet of the regulators for them to consider how to adopt or how to write some of these G-27 packaging standards into regulations. So right now, very much still in development. The committee, we've been a part of it since its inception, and the people that do the work there, we're all committed to getting something to improve transport safety, but it's a long process. We all expected it to be a long process because there are so many different variables and factors that we need to consider. We're just kind of moving that ball forward to say, okay, now that we feel comfortable in terms of the standard as it relates to lithium-ion cylindrical cells, what about pouch format? What about prismatic cells? What about batteries? How do we incorporate lithium metal? What, if anything, do we do with new chemistries like the solid states or even some of the new sodium ion cells and batteries that are hitting the market? So the work goes on, and we're hopeful to keep pushing this ball forward to get something to improve transport safety.